Wishing you all a good morning. Let's continue with our session. So, welcome to our CCNA, to be specific, CCNA-1 Introduction to Networks. So far, we have covered 4 topics. This week, we'll go through topic number 5 and 6 as well. Okay. With the morning group, I'll do number 5, and with the afternoon group, number 6. Now, if some of you are free during the afternoon, you can join in during that time as well. Okay. If you are not, then just look at the recording. So today we'll be going through number systems. This is an important aspect of CCNA and Datacom and Network Management because our IP addresses follow certain number systems, and we have to understand the conversion between some number systems that are specific to us. Typically, binary and hexadecimal. Okay. You know that the computers, the machines, they only understand the language of bits and zeros. Okay. So we have to learn how to convert from our daily usage of decimal to binary, and from binary how to convert to hexadecimal, and so on. So that's why this topic is important. And today we'll be learning exactly that. What is a binary system? Calculate numbers between decimal and binary systems, convert from decimal to binary and binary back to decimal. You have to, if you're a network engineer, you have to be quite fast in the conversion. Okay. It would become a second nature to you. And you will also learn how to calculate and convert from decimal to hexadecimal. Okay. So nothing new. These are some things that back in school we all have studied. So we start with a binary number system. We know that our machines only understand the language of ones and zeros. Okay. 1 being a 5 volt of electric current and 0 being a 0 volts of electric current. Now, a combination of all these, a combination of ones and zeros arranged in 8 bits makes all the characters that you have on your keyboard. Okay. The same goes for your IP addresses. Okay. Specifically, when we talk about IP address conversion to binary, we are talking about IP version 4. Because IP version 6 is converted into hexadecimal format, but IP version 4 is converted into binary format. Okay. So if you have got these binary formats, how do you convert? What is the conversion? Okay. Why the highest number that we have over there should be 255? Why can't it be 256 or 257? Why the last number should be 255? Why the first number should be 0? You know, there are reasons for that, because when you convert it into binary format, the machine only understands binary format. The binary format that it sees is either a combination of zeros and ones. So the first combination is 0, 0, 0, 8, 0. If you convert it into decimal, it would be 0. And the last conversion would be 8 bits of ones. So 8 bits of ones, that means if you convert it, it becomes 255. That's why you cannot go beyond that. Let's have a look in detail. So as I told you, Binary consists of ones and zeros. We call these bits. Okay. Decimal numbers, which enable us to do calculations faster, are a combination of numbers from 0 to 9. Okay. Every network equipment that we have, maybe computers, servers, uh, switches, routers, all of them, they use the binary addressing system to identify each other. They use what you see on the left. Okay. What you see on the left is what they use. Okay. This is the number system that they use. But what we use is the one on the right. Okay. So the conversion happens and the machines only understand this. Okay. But we see this binary system as our decimal system. Okay. And make sense of it. Now, if you look at it, every IP version 4, we're talking about IP version 4. Every IP version 4 address is made up of 32 bits. Okay. Why do we say this is a 32-bit address? Because you see 8 plus 8 plus 8 plus 8 is equal to 32. That's why we call it 32-bit address. Every octet consists of 8 bits. Okay? These 8 bits will make up one character. So here 209 is 1 byte. Okay? And we separate it with a dot. So 110100001 converted into decimal is 209. Okay? And so on. We can also use this, but it will be very difficult for us to understand the binary system. Okay? We have to do mental arithmetic the whole day. If we have network engineers, okay, which can drive us nuts. So we rather look at this, okay, and do our calculation based on this. But you have to learn how to convert this into this fast, and from this into this, binary to decimal, decimal to binary, okay? Especially if you're going into networking as your career, okay? This would be uh, something like a second nature to you if you go into this career. Now, let's go into more details. First, I would like to ask you, how many networks do you see in this topology here? In this topology, the left one shows you the binary numbering system, and the right one shows you the decimal binary system. So in this IP version 4 topology, how many networks do we see? Anyone? Look, you have a router right over here. And I have already told you a router is used to connect different networks together. Wong says 4 and then changes to 2. Uh, um, okay. What do you think? Anyone else? You're very close, Wong. It's not 4 and it's not 2. It's the number between them. Okay. So here, you see, this is the one network. This is the second network. And here is your third network. Can you see? Okay. 3 networks. Here. This is the first network, second network, third network. Doesn't matter which number you give them. There are 3 networks which this router joins together. Okay? So, that being said, now you have to ask yourself, what is this /24 for these networks that is used? Can you see? 192.168.10.0/24. Now, 192 is converted into binary format again /24. Okay? /24 has got a specific meaning. /24 means there are 24 bits for the network address and 8 bits for the host address. Remember, every IP version 4 consists of 32 bits. So over here, I'm saying that, hey, 24 bits of this address, that means 8 plus 8 plus 8, 24. That means the first 3 octets belong to the network. That means 192.168.10 will never change. Okay? /24. That means these network portion will never change. What will change is the last 8 bits, which is the 0 section. Okay? So here is where you can actually give your IP addresses, okay, at this section, because 32 minus 24 is equal to 8. Okay? So the host address is only 8 bits. So you can write it like this, or you can give a subnet mask. Okay, sorry. You can give a subnet mask. The subnet mask would be there. When you say, once again, when you say 24/24, that means 24 bits out for the network. Just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So you have got 24 bits. So these ones, whenever you see ones, remember that is the network portion. Whenever you see zeros, remember that's a host portion. How many zeros do we have? 1, 2, 3, 4, 5, 6, 7, 8. So right over here, 24 means there, all the ones. That means 24 bits are for network address, like this. This is the network address. And 8 bits for the host address. Okay? So, if you say 8 bits for the host address, that means you can either write it in this way, or you can also mention it in this way. So, /24 means subnet mask 255.255.255.0. Because if you convert this into decimal, if you convert this binary number into decimal format, it will be 255. So instead of representing it in this way, we can also write 255.255.255.0. We call this subnet mask. Why do we need a subnet mask? Because once you're given a subnet mask, you know which one is the network portion, which one is the host portion. In this case, the moment you see 3 255s, you immediately know it is 24 bits for network, only 8 bits for the host. So, my dear students, you have to get used to this. Okay? So, this kind of calculation is actually how you do things. Okay? Now, once we are given this /24 or subnet mask, then we can immediately find out what is our network address. So right here you can see LAN A, local area network A. The network address is 192.168.10.0. Okay. The 0 section means we can manipulate and put the IP addresses. Okay. Now, another thing you will observe here is the router is like a connecting bridge, okay, between all these networks. You see, the gigabit Ethernet of the router, which is interface G0/0/0/0, has got the same network address as in the network. And usually, the first IP address we give to this gateway. Okay, so the gateway to this network, LAN A, is this address. The gateway to LAN B is this address. Okay. Remember in your packet tracer, when you give your network address, it asks what is your gateway. For example, if you're giving IP address to this, it will ask what is your gateway. The gateway address would be this. Okay. That is the node from which you are going out. The gateway address for this computer, let's say it's on the internet, would be this. Okay, an example, or on the cloud or whichever. So this is how IP version 4 addresses are given. Okay, and this is how they are converted as well. Now, the question is, what is the number of devices you can add? For example, how many hosts? There is a calculation which you follow. Okay, how many hosts? Okay, 8 bits. Okay, so when you say 8 bits, so that means you have to do the calculation. Okay, 2 to the power of 8. Okay, what is 2 to the power of 8? Take your calculator and calculate, all of you. Anyone? Very good. So 2 to the power of 8 is 256. So the formula is 2 to the power of 8 minus 2, which is equal to 254. Okay, so always count the host bits, and then say, for example, here is 8 host bits. This is the formula we calculate how many devices we can add. 2 to the power of 8 minus 2. So in this network, how many IP addresses I can give? 254 IP addresses can be given, from 1 until 254. Get the idea? This is how we calculate. So how do you calculate for this? Okay, how do you calculate for this /16? Slash 16 means 16 portion is for the network, 16 portion is for the host. So how do we calculate that? We say 2 to the power of 16 minus 2 is equal to that many hosts. Get it? So this is how we calculate how many hosts we have. So the host portion, if it is larger, that means you can add more hosts, more computers, more devices. Maybe not just computers, any device with a network interface card can be added to the network. Okay, so we'll be studying these over and over again, so much so that these concepts will be really in your mind and you will never forget them. Okay, so this is how IP addresses are given. When we talk about decimal numbering system, you see, decimal, if you look at the decimal numbers which we follow every day, is on base 10. Okay, starts at the 1 position. Okay, 10, 100, 1000, and so on. So if you want to say 1000, if you want to represent 1234, we know at the 1's position is 4, at the 10's position is our 30, 100's position is the 200, and the 1000's position is 1000. Okay, so this is how we do our decimal number calculations. It's fast, it's smooth, and we have been following this since forever. Okay, except the ancient times, where they had different numbering systems and so on. The same if you go for the binary. In the binary, it is base 2. Okay, and in base 2, you see, again, 2 to the power of 0 all the way until 2 to the power of 7. So you get this order of numbers: 1, 2, 4, 8, 16, 32, 64, 1 to 8. Now you have to remember this order from right to left, or you can say from left to right. First is 1, then is 2. You can just close your eyes and keep on saying 1, then 2, then 4, then 8, then 16, then 32, then 64, then 1 to 8. Okay, go from the other way. Close your eyes and keep, because the reason you have to remember this order, these positions, is because calculating, that means converting from binary to decimal and decimal to binary becomes fast. Example, if you have got a binary number 11000000, and you are asked to convert it into decimal, you can just look at the 1 position. For example, this 1 position is at 1 to 8. And this 1 position is at 64. So what is 1 to 8 plus 64? Answer is 192. That's it. Convert fast. Okay. We have learned this conversion when we were in school, but then maybe we have forgotten it. So it's time to catch up and keep on doing this, so become faster and so on. You can do the other way as well. Okay. Let's just go fast. You see what we do here? Convert 1 1 0 0 0 0 0 0. So again, it is at the 1 to 8 position plus 64. 1 to 8 plus 64 will give us 192. Okay. What about this? This is at the 1 to 8 position, at the 32 position. Okay. So 1 to 8 plus 32 plus 8 position plus 8. So 1 to 8 plus 32 plus 8 will give you 168. What about this? Okay, it is at the 1 position, the 2 position, and the 8 position. So 8 plus 2 plus 1 will give us 11. What about this? It's at the 2 position and at the 8 position. So 8 plus 2 will give us 10. Okay, keep doing this. Okay, so you become fast. If you want to do the other way, if you want to convert your decimal to binary, okay, then there is a quick way that you can do it. And that quick way, I'm sure all of us have studied. Let's just go through it again. Whatever number is given to you, just start from the left and see whether it's greater or equal to 128. If it is greater or equal to 128, then you start with the first one. Okay? And then whatever number it is, minus 1 to 8. Then the second number that you get, you do the same thing. Move to the next number and so on. Okay? Let's look at an example so we understand it better. Okay? So convert 168 to binary. Is 168 greater than 1 to 8? Yes. So put a 1. Okay? And then 168 minus 1 to 8 is equal to 40. Then go to the next number. Is 40 greater than 64? No. So put a 0. Is 40, then go to the next number. Is 40 greater than 32? Yes. So put a 1. And then 40 minus 32 is equal to 8. Is 8 greater than 16? No. So put a 0. Is 8 greater or equal to 8? Yes. Remember, it should be greater or equal to. Yes. So put a 1. And then 8 minus 8 is 0. So there are no more values left. So the remainder numbers will be 0. So this is the quick conversion that we do from decimal to binary. Now back in school, we were taught to do it in this way, remember? Okay? At least I was taught to do it in this way. I don't, my teachers never taught me this one. Would have been nice if we learned this. Okay? So this one would be much more faster. So remember, every hardware device that we have, intermediary device, hosts, IoT devices, they need to be given an IP address. And that IP address they give is a machine IP address. Now we have to convert it into a decimal one so we understand it. This is in terms of IP version 4. Now let's go to hexadecimal number systems. We understood some concepts of binary and decimal. Now let's go to hexadecimal. Why do we need hexadecimal in the first place? That's the question you should ask. Why hexadecimal? Everything becomes binary. Why do we have to worry with hexadecimal? There's a reason. The reason we have to understand and deal with hexadecimal is because our IP version 6 and our MAC address, they are in hexadecimal. Okay? That is the reason. So, how do you convert from decimal to hexadecimal? You have to convert into binary format first. Okay? So, you convert your decimal number, okay? You convert your decimal number, for example, here, 6, you have to first convert it into binary. And then from binary, you can convert it into your hexadecimal. You pair it into 4 bits, and then you convert it. Hexadecimal starts from 0 until 9, and then A until F. Okay? So IP version 6, in IP version 6, remember, your IP version 4 is 32 bits. IP version 6 is 128 bits. Now, look at the range that you can have in IP version 6. Okay? Here, the first 4 will be the network. The last 4 will be the host. Okay, it's very straightforward. It has been created to be straightforward and not confusing like your IP version 4. Okay, first of all, why did they come out with IP version 6? Because public addresses for IP version 4 is exhausted already. So they needed a new IP numbering system. So they came out with our IP version 6. And the range of IP version 6 is so huge that we are not going to run out of these addresses for more than 100 years. Okay? So don't worry. No matter how many devices you have, you can still use this IP version 6 addresses for a long time. Okay? The exact year, I'm not so sure, but they made a prediction. I think it's in one of our future slides. We'll look at that later. So anyway, when you look at your IP version 6 address, okay, so each of these, you see IP version 4, each of these we used to call it octet. But here we call it hextet. Why? Because each is 4 bits. Okay, each of this is 4 bits. So 4 times 4 is 16. That's why we call each hextet. So how many hextets we have? 8. 16 times 8 is equal to 128-bit address. Okay? So each of these is 4 bits. So if you count from here, again, 4, 4, 4, all the way, you have got 32. So again, 4 times 32 is, you get your 128 bits. Okay? Each hextet consists of 4 hexadecimal digits. Okay? That would be 6 binary digits, each of this. Okay? So you will have a notation here, a notation here, a notation here, a notation here. Okay? That value is hexadecimal. So look at the range that we have. So when you give an IP version 6, you have to perhaps look at the hexadecimal value, and that hexadecimal value will have 2 parts, the network portion and the host portion. Very similar to your IP version 4, only easier. The challenge is converting from decimal to hexadecimal. Always remember that there should be a binary in between. Okay? You take your decimal, convert into binary, and then group it into 4, starting from the rightmost position, and then convert into equivalent hexadecimal value. 168 is converted into binary, and then this is grouped into 4. Okay? There, 1, 4. Okay? And then 1010 is A, and 1000 is 8. So 168 is A8. How do you know that? Look at the table. Look at the table. Okay? So the conversion becomes easy. Another example, from hexadecimal to decimal. Again, binary is between them. First convert it into binary format. So D2, okay, D is 1110 and 2 is 0010. So when you join them together, okay, so quickly convert into decimal. 128 plus 64 plus 32 plus 2, which is 210. Okay, remember the positions. 1, 2, 4, 8, 16, 32, 64, 1 to 8. Just add up the sections where you have a 1. Okay? So we come to the end. Today we learn about the base 2 binary numbering system and base 10 decimal. We also learned about the base 16, which is our hexadecimal numbering system. Why are we learning hexadecimal? Why is it important? Because our MAC address and our IP version 6 address is represented in hexadecimal. The benefit of having IP version 6 is it's 128 bits compared to only 32 bits of IP version 4. So that means it covers a huge range of devices and future devices which are not yet created. Okay? And whenever you convert from hexadecimal to decimal and vice versa, remember, you have to first convert into binary first. So that brings us to the end of our number systems. Anyone has any questions? Okay. Now let's talk about today's lab. What we are going to do today is we are going to use a software. I uploaded a video late last night with a link on Moodle about how to install Wireshark. Okay? Wireshark is a very interesting software, actually a very dangerous software. It is a protocol analyzer, a packet sniffer, which can actually look into your network. Okay? So what does this software do? It is used for troubleshooting your network, for software and protocol development, for education, for analysis, for research. You can do so many things with it. And many enterprises, they ban this software. You cannot just install it without permission. Okay, Daryl, your wish has come true. Okay, so before you do any installation, I want you to just observe what I'm doing here. So you can see my network over here. Okay, some things that I have disabled, I don't want you to see. But you can see my Wi-Fi. Can you see my Wi-Fi? Okay, you can see my Wi-Fi network. Um, let's go and do some activity. Okay, let's just double click Wi-Fi. You see the details. Okay, you can see the details. Okay, source. So you can see the source. Immediately you can see my IP address. Okay, and which destination and what kind of communication is happening. The details, you can actually stop this, okay? And you can save this and go and study it in detail. You see all the acknowledgement packets? Can you see? What you have been studying in your lecture is literally, you can see it happening right in front of your eyes. Okay? Here you can see the details of the frame. And here you can see conversion from your numbering system to your actual meaningful uh, translations, if that makes sense to you. Okay. So again, if I want to continue, it says, do you want to save it? Just say continue without saving it. Shows you a new one. Okay. So it's a very interesting software. And wait, stop. Let me start it again here. Okay. There, look at my Wi-Fi activity. Okay. If your Wi-Fi is silent, so you will get a flat line over here. And then if you do some activity, like let's say I go to, let's say we open BBC website. Okay. So when I go to the BBC website, you can see there's a spike in my Can you see the moment I open a website, there's a spike. So this tells you the details.